Hello colleagues, I'm really glad to see each one of you today in our event. I'm Igor Borodovsky, Sales and Support Engineer of Woodwork for Inventor team, and today I'm proud to present the new features of Woodwork for Inventor version 11. So we will have a comparison between 10th version and 11th version, and it will be interesting for you to see what new features we have developed. And we will start from versions. The newest version of a Woodwork is compatible with Inventor 2021. Now, speaking about the materials, let me show you what new features we have here. And I will start from multi-layer materials. And first, let's see how we can make multi-layers in the 10th version, in the older one. So in order to have a multi-layer material, there was like some routine procedure. We must use material editor and make a new definition, define the code and the name of the multi-layer material, choose the appearance, and then we must apply the layers to define what thickness of those materials would be in our multi-layer sandwich. That's how it looked. And then, when it's finally done, we must enable this material in the palette to make sure that it's available for our needs. And only then you need to go back into the material assignment and then choose this newly created multi-layer material and apply to the panel. And then on the BOM we'll get like multiple layers for this desktop. Okay, as you can see now, for the desktop in a BOM we have multiple layers. Now let's compare that with 11 version and see what procedures we have there. First of all, we don't need to go to the material editor. We can directly make a new multi-layer board. So there we can define the code and the name, like so, choose the appearance, and then apply the layers. As you can see, some of them can be floating, and there is one more new feature. In the 10th version, only one layer could be floating. Here we can choose more than one. And again, we are choosing the layers. As you can see on the left, it shows you the preview of the sandwich structure. Okay, so you can indicate what the thicknesses of the layer would be and so on, and you can define for what kind of board you'd like to have this sandwich, or you can pick this board from the model if you like. There's the sample picking tool on the top that allows you to indicate what is actual layer you want to apply this sandwich to. Okay, and there is two ways of how you can keep this material. You can keep this multi-layer in the database, or you can make it local. So in case if you haven't noticed the difference, there is two icons shown on the top. You can see that if you keep the material in the model, it will be dedicated for this exact component, for this exact desktop in this exact assembly. But if you find that this multi-layer structure may be useful in your future designs, you can keep this material in a database and it will be available for all participants of your work process. Now let's take a look at the material replacement. And again, I will compare that with the 10th version. So if you use a material replacement like a standalone command or in the BOM section, you may see how it looked in the previous 10th version. So you can see there's like quite a lot of buttons. You can expand and collapse the definition. You can see a current material and a new material like after the replacement. So for new users especially, it was like quite confusing experience because it was not very obvious what is happening. So we decided to streamline this user experience and change the UI a little bit. And now this user interface looks a little bit differently. So you can see there's two tabs, material and color replacements, and they works in a similar manner. So what we can see here, we can see that there is like streamlined interface when you only have new replaced data. So there is no need to see previous default materials. You can only see what is the current material and that's it. There is some more options like write protection and so on. We will discuss that later. But for now, you can just visually compare how the interface changed. The materials in the editor grouped by the type, and the same type of the material can be also split into the thickness. Yeah, so different thicknesses will be shown in different groups. So this allows you to very precisely and clearly define what your furniture is made of. Now, since I mentioned the functionality about locking the materials, let's take a deeper look at how it happens. And it's only new functionality in the 11 version. There is no similar things in the 10th. So let's quickly see what do we have here. Let's expand the selection, and you can see that we have some materials set as a replacement. Okay, so I can choose another color scheme, and you can see that all the materials changes. Now, if I apply material replacement, it also changes the appearance of the model. But I can remove the selection of some of the components and then write this material directly into the panels. Okay, so then if I choose another color scheme, let's say light, for instance, so you can see that materials that was written into the model appears the same, so they haven't changed. Okay, and you can see that this allows you to quickly define a new color scheme, keeping those materials intact. Okay, so let's say I'm using another color scheme, and now I can apply the material replacement again. And in this case, we can clear the replacement that we had here using clear button, like so, and it again became light. So all the panels will be light again. So there is no need to write the definition of the material into the document. If you like to protect them from accidental changes, you can just use a lock mechanism. Okay, so we can write some data into the panels, and you can see it marked as a written into the document. Okay, if you do changes, it only changes the object that was set not write protected, like so. And now let's mark some of the items and make them locked from the changes. So I haven't written everything. Yeah, so just marked some selected items as locked from changes. Okay, and now if I change the material, you can see that only the component that was not protected from the write and not written down into the components was changed. So there is like 2 degrees of freedom, if you can name it like that. We can write the materials into the components, or we can set them write protected. And of course there is an opposite command, unlock, which just allows you to unlock the changes, and again you can just reapply your default color scheme if needed. Now let's speak about the size calculation of the items in 11 version, and in some case it might be that the part length should be calculated along short edge. For instance, in this case, imagine that we had a profile, but this profile actually will be shrinked. Okay, so for the part calculation direction, okay, we can see that it goes along the longest edge right now. Now if I change the parameters which controls the length of the profile, it might be that the height of this profile or width of this profile is bigger than its actual length. And if you start your material assignment exactly at this moment, system can treat the width as the direction in what the length should be calculated. Okay, so as you can see, that's the grain direction. So you can define how the grain will be calculated. So you can see that the part length calculation will be in parallel with the grain direction. Okay, so you can just set the grain direction for the profile and say that the length will be measured along it. Now let's speak about the cover materials. And sometimes you may need to apply some labels on the materials to make their representation more clear. Okay, so if you go to the material editor, there you can see that some cover materials may have additional label value. Okay, and you can define some label for the cover material. And this label can be shown in various places. It actually depends where you would like to see it. For instance, in the drawings, especially in case when you use an edge banding or something similar, like veneer on the edges, you may define the label position and the way how they will be represented. Let's take a look what can be done here. Okay, we are using some BOM template, And there's one more new feature, we will speak about this later, but for now you can see that there is a new keyword called item material label. You can just see how it performs on the drawings. Those labels can be shown not only on the tables, but as well on the view of the part on its own. So you can see there's the part on the bottom, and we have a demo labels for the edge banding. Of course, this label can contain some different information. It depends on the adjustment. Speaking about the edge banding, those of you who are familiar with our system knows that we may apply some Premill allowance for the edge banding. And some of our clients used Veneer as an edge banding. We have a good news. There is a tool which allows you to define the Premill allowance for the veneers. So you can see there is an option, apply Premill allowance for the components. Okay, in this case it was set to 0. Select where this material should be defined, and there's like a marker of 1 millimeter which indicates what is actual situation. Okay, so you can see that in this case, okay, we have the Premill allowance set to be 0. Okay, now in design settings we can apply some Premill allowance. Let's make a huge Premill allowance to make it easy to see. And then I will apply this for veneer edges as well, because we applied the veneer, and you can see that the workpiece became way bigger than it was before, since the Premill allowance was set. Now let's speak about what new we have in the iBoxes, in those smart components. In 10th version, when we placed the iBox, there was not a lot of options about to define the position where this new created iBox would be placed. Okay, so when I place some of the components, I can only place it into the subfolder, and then it inherits the root name of the folder where this iBox was placed. Okay, let's define the position, like so. And then you can see that it have a like copy in the front of the main name of the folder. Okay, if you have those names defined in the right way on the iBox library, there might be not a big deal and it works quite well, but it might be that you want to have some more flexibility. So that's why we developed some more advanced way of defining the folder in the 11th version. You can be more precise in the naming scheme. So you pick the component, and there you can have a subfolder name defined in the way you want. Okay, again, you can define the prefix, suffix, and a subfolder name. So now let's try to place the component again. And now let's take a look at the location. This component will be placed in the renamed subfolder, and the components will be named according to your naming scheme. Now let's take a look at the BOM. And those of you who work with the BOM templates knows that sometimes it's quite difficult to pick the right keyword for a template. It actually defines what kind of the data you want to see in your report and where and how you want to process that data. So that's why we have a new keyword preview option in the BOM editor, which allows you to actually see the results of the keyword without actually generating the BOM. Okay, on the column section you must enable keyword preview, and in this case it will be the last column, but of course you can move it in the front if you like. So there is a keyword preview, and there is when this keyword preview option is set in the columns, now the keyword preview input field becomes activated, and you can type the keyword. As you can see here in the keywords, we also have some restructurization. Those keywords have more description things. Yeah, they tells more about them. And as you can see, that's the result of the keyword on the very right column. So you can see what the result it returns. It can be like material type, material code, material name, blank width, whatever you like. So you can just find the right keyword and then copy that keyword in your template file and then use it in your final output. Speaking about the final output, there is something more interesting features, which we call like conditional definition. So this allows you to define some, let's say, rules on the template. And according to those rules, we will apply one formatting or another one. So you can see that, for instance, for assemblies, we have one set of the data which actually just shows the image. And if the item type is equal to the part, we have this set of data shown in green. Let's take a look at the result, what we're gonna receive, what we're gonna get in the result. Okay, so you can see that we have an image of the assembly as we expected, and then we have some more advanced definition of the parts. And so you can see that for the parts we have a edge definition, what cover material was applied, but for the assembly we have only the image. So let's take a look at the grain calculation. So you can see that we have a keyword like part by grain. This keyword allows you to calculate the length of the part by the grain direction. Those of you who are utilizing QR or barcodes, we have a good news, because now Woodwork knows how to deal with that situation. Now let's take a look. What do we have? So we introduced the QR and barcodes keywords, okay, in the 11th version. So you can use barcode standard 128, and then you can just type what you'd like to get in that field, like item code or item length or whatever else, and it will be coded like the barcode. Or you can use a QR code as well. By the way, there is like a new template in the template folder just called What's New. You can see how it works and what results does it gives you. So as you can see here, we have not only QR and barcodes, but we can also indicate the preview of the part with the thumbnail of the drawing if you have it. The reference status for the Occurrence in 11th version changed its behavior. So let me remind you, what does it mean? It might be that you have two or more identical references, and maybe you don't want to see one of those in the BOM for some reason. Okay, so maybe you want to hide one of them from the BOM. Maybe you manufacture one of them and purchase the other one or something similar. So now you need to change only the BOM structure for the instance, but not for two of them. So we change the status for one of the instances, and now on the BOM, the second one will be ignored. As you can see, one of them is set to the reference, it will be ignored in the BOM. Yeah, we had two instances, but we have one here. Okay, if we go back to the Occurrence and change it back to default, it will return to the normal behavior. Okay, so you can see now we get them back. Now let's take a look at the quantity summary keyword. So as you see, we introduced a lot of new keywords. Maybe I'll not cover all of them and just touch some important things. You can find more of them in the keyword constructor. So let's insert a new row and let's give it a name, like a total quantity of an items. And here I can use a new keyword, which is like item.quantity sum. Okay, and I can just use it here for the header, for the data description, and for the sub levels, because we can have different formatting depending on the sub levels. So let's take a look how it works. Okay, so it actually shows you the total quantity of the items. The next one is called row index keyword, and it's useful in long lists when you have like a big structure of your exported data. So you may need to find something in your list. So we can use a row index keyword, which actually brings you the row index. Okay, and that's the result. Now let's speak about the BOM by products. If you have like big assemblies, which is not the case on this sample model, we have only two divider subassemblies. So you may want to get documentation for each of those subcomponents. And in the previous version, you must set the structure to be phantom, structure of the main assembly to be phantom to indicate the components in that way. In the 11 version, there is no need to define BOM structure. It's normal. Yeah, there's no need to set it to be phantom. You can just get material summary by products directly without the need to set this top level to be phantom. Okay, as you can see, we have a normal structure now. And if you'll produce actually the same specification, you can see that we get similar result. Now let's take a look what changes we have in the edge banding legend in the version 11. Basically now we can get the data about the legend in a more elegant way. Okay, so you can see that we have different conditions like tangentially connected edges, point touch, or indirect edges, like so. So you can have individual prefixes or suffixes for those kind of edges. Okay, and there you can define what data you'd like to see. So you can get this data in two ways. You can use a keyword legend, or you can indicate what actual data you'd like to see. Okay. So now you can define this legend for individual conditions. Okay, so now let's take a look at the coordinate system, and as you can see, it indicates where is like a coincident constraint, where is like direct connection, and so on. Okay, so you can see on the left we have like coincident joint, point touch, yes. Like this veneer is touching only on the point. Okay, another one is also touching on the point. So that's how you can see more information about the situation of the edge banding on the BOM. So now let's take a look at what new we have in the hardware. And first of all, we added few new items here and there in the library. It's not a lot, but some of them was improved. Some of new items are presented. And now let's take a look at some long-awaited features, and one of them will be adaptive sculpt. So you know that in the previous version, when you change the position of the work planes, you basically need to rebuild the sculpt, and it leads to some bad consequences in the drawings. If you set dimensions in the drawings, you need to redefine them again. Yeah? Because when you do sculpt in the 10th version, in case if you change the position of the hardware, the old geometry disappears and your annotation also have no references. So that's why it led to the need to change something on the drawings manually to set a new reference points. Now in the 11th version it works way better. So we can use some associative option for the sculpt, and now you can see that if I change the position of the hardware, or if I change the work planes, which actually drives the position of the hardware, you'll notice that the holes automatically changes. So there is no need to do the sculpt again or something, so you can immediately see the changes. So under the hood we use adaptive functionality of Inventor, and you need to be careful with that, because adaptive design in Inventor have some nuances, let's name it like that. So you need to know how the adaptive feature works in Inventor, because we have the same restrictions in Woodwork. Okay, now let's take a look at the hardware replacement tab. I already mentioned that quickly, but we haven't discussed it. So basically the thing is that on the material replacement we have a separate tab for the hardware replacement. So we have two things in one window. It also can be found on the BOM editor, not only on the replacement, but on the report section as well, the same window. Now there is like some specific feature useful maybe for a few of us, and it's related with the hull nodes embedded into the hardware. Okay, so I can apply some hull node in a hardware. So I can give it a name and define the condition when this node appears. So for instance, I can give a comment, give a name, and then I can define the tolerances if needed, like so. Okay. And then I can write this node exactly into the hardware. Yeah, so I can say that this will contain that node or another one, and this node will be embedded in the hardware. So in this case we have like two different tolerances for a pillar board and for a nested board for this dowel. Okay, and then if I use this hardware, let's take a look what will happen. Okay, I just use a regular workflow to place the hardware items. Okay, let's close it and see what we will get as the results. Now let's apply the sculpt command, and I can select individual boards I want to sculpt. Okay, to speed up the process a little bit. Now let's take a look what do we have in this board. So this side panel now will have annotations. Okay, if you apply hull nodes, you can see that it actually took the hull nodes from the hardware definition. Let's move to another topic. It will be the drawings. So maybe you already noticed some tables in the drawings. Now let's take a deeper look at what we can see there and how they work. Let's take a look how we'd like to define the tables. So this can be done on the template. Okay, so let's go to the template setup and see what can be done here. Choose the one we'd like to adjust. Okay, and now in the autoplot setup, you may see some additional options, like beside the standard things, you see that we can define the actual template file for the output of the part and a drawing of the assembly as well. Okay, so what you can see here is like a regular drawing of woodwork, but on top of that you'll notice two tables. One is set for the material definition and another one is set for the part composition. Yeah, so we have, let's say, edge banding legend as a table, and we have a composition of the part. So which is useful in case if you have like custom structured parts. Yeah, and also of course we can export the definition of the assembly. If you like, you can actually take a piece of BOM and place it into the drawing of assembly. Speaking about the CNC, what do we have here? The list of the post-processor was updated. I will not explain each of those post-processors. Those of you who waited for some post-processor maybe already noticed the item in the list. And of course, the post-processor story is a little bit different. Basically, you need to actually contact us directly in case if the post-processor is needed, if it's not listed here, so we can help you with that. But now the list of the post-processor was expanded. We have more of them now available out of the box. Now let's take a look at the operations, what we can do with those new post-processors and new features of Woodwork. And first of all, we can apply a sizing operation using a saw. The sizing operation used for different purposes, for misaligned workpiece on the laces, yeah, or for some precision calibration, for different purposes. So there I can define the condition. I'll just do this manually to make things easier to understand. Of course, this can be also done automatically, and here you can choose different spindles for a left and right cut and different spindles for a front and back cut. Okay, so you have like a sub options here, and when it's set, you can just see how the simulation works, what result does it brings you. As you can see, we do a calibration by a saw blade. In the previous 10th version, you can only do this by a milling. Speaking about the pocket operation, we had the problems in the previous version when we got some islands, so when it was not even surface. And now Woodwork knows how to deal with that situation, so we can just mark the pocket. Okay, and it knows how to deal with that. So we can just quickly go around circumferences and get the pocket with the Iceland done correctly. If you have some cutouts in the panels, we can ignore them. So I can define some ignorance criteria on the opening. Okay, so I can define how much is the size of the opening that need to be ignored. And if not, this opening can be treated like two different operations. Yeah, like I can apply milling or pocketing, or I can say that this hole must be ignored, and then I can just do the pocket for entire cutout, and then only make cutout in the middle. So it both options available. You can remove pocket in the way as this hole would never exist and then do the cutout, or you can do the cutout and do the pocket around it. So it actually allows you to do both scenarios. Now there is something with the simulation. It might be that in case when you're using correction on air, in some places this can be enabled or disabled. So now the simulator allows you to see what result you will get if this option is set in a proper way. So actually you see that it damages the part. Yeah. So in this case we see this trapeze shape on the left edge, which means that something definitely goes wrong, and maybe we set the correction on air option in the wrong way. So if for this machine it must be enabled, you will notice that on the part you will get like damaged contour. You can see that some measures need to be taken to fix the situation. Okay, now let's speak about the vault a little bit. There is some small tweak here. It's not a lot, but nonetheless it exists. So it was about primary associated file. In the previous version, the primary file was the last one checked in. It was an MPR file. But it turned out that for some of the users, it's not correct. Yeah, and they wanted to have like a native behavior as it happens in Inventor. So we can now we can treat the part as primary associated file. So this is like the main unit, and all the things belongs to it. So that's all the information that I'd like to share with you today. I hope that this short discussion was interesting for you. Thanks again for coming. Good luck. Bye bye.